This episode is brought to you by Magic Spoon. Magic Spoon is a brand new cereal that I eat just about every day that is low carb, high protein, and zero sugar. I just ate a huge bowl of their cocoa flavor about an hour ago after a short workout. Magic Spoon cereal has received a lot of attention since launching last year. Time magazine included it in their list of best inventions of 2019, and Forbes called it the future of cereal. It tastes just like your favorite sugary cereal from childhood, remember that? But it's actually good for you. Each serving has 11 grams of protein, 3 grams of net carbs, 0 grams of sugar, and only 110 calories. It's also gluten-free, grain-free, keto-friendly, soy-free, and GMO-free. All the things. It's delicious. And I don't say that lightly because most of this healthy version of X stuff is not delicious, but these guys really nail it. Magic Spoon has nailed it. It comes in your favorite traditional cereal flavors like cocoa, frosted, and blueberry. You can try them all by grabbing a variety pack at magicspoon.com/Tim, or you can just grab a box or a bunch of boxes. I'm going to order some more today of the cocoa, which is my personal favorite. But there's a new contender for favorite flavor because they just launched 2 limited edition flavors, honey nut and peanut butter, which are delicious. I am a sucker for peanut butter, and it is outstanding. So I think cocoa and peanut butter are my 2 new favorite flavors. And fun fact, my friends are also obsessed with Magic Spoon. One of the podcast's most popular guests, Dr. Peter Attia, routinely crushes 6 to 7 servings at a time. That's a lot, with no glycemic response. He's looked at this with a glucometer. He likes it so much he invested. Other friends, 2 very fine gentlemen and also past podcast guests, Kevin Rose and Ryan Holiday, also invested. So go to magicspoon.com/Tim to grab some delicious cereal and try it for yourself today. Use promo code TIM, that's TIM, at checkout to save $5 off of your order. And Magic Spoon is so confident in their product, I have boxes and boxes and boxes. It's backed with a 100% happiness guarantee. So if you don't like it for any reason, they'll refund your money, no questions asked. Get your next delicious bowl of guilt-free cereal at magicspoon.com/Tim and use the code TIM to get $5 off. This episode is brought to you by 8 Sleep. My God, am I in love with 8 Sleep. Good sleep is the ultimate game changer. More than 30% of Americans struggle with sleep, and I'm a member of that sad group. Temperature is one of the main causes of poor sleep, and heat has always been my nemesis. I've suffered for decades, tossing and turning, throwing blankets off, putting them back on, and repeating ad nauseum. But now I am falling asleep in record time, faster than ever. Why? Because I'm using a simple device called the Pod Pro Cover by 8 Sleep. It's the easiest and fastest way to sleep at the perfect temperature. It pairs dynamic cooling and heating with biometric tracking to offer the most advanced but most user-friendly solution on the market. I polled all of you guys on social media about the best tools for sleep, enhancing sleep, and 8 Sleep was by far and away the crowd favorite. I mean, people were just raving fans of this. So I used it, and here we are. Add the Pod Pro cover to your current mattress and start sleeping as cool as 55 degrees Fahrenheit or as hot as 110 degrees Fahrenheit. It also splits your bed in half, so your partner can choose a totally different temperature. My girlfriend runs hot all the time. She doesn't need cooling. She loves the heat, and we can have our own bespoke temperatures on either side, which is exactly what we're doing. Now, for me, and for many people, the result, 8 Sleep users fall asleep up to 32% faster, reduce sleep interruptions by up to 40%, and get more restful sleep overall. I can personally attest to this because I track it in all sorts of ways. It's the total solution for enhanced recovery, so you can take on the next day feeling refreshed. And now, my dear listeners, that's you guys, you can get $250 off of the Pod Pro cover. That's a lot. Simply go to 8sleep.com/Tim or use code TIM. That's 8, all spelled out, EIGHT, sleep.com/Tim, or use coupon code TIM, TIM. 8sleep.com/Tim for $200 off your Pod Pro cover. Optimal minimal.
At this altitude, I can run flat out for a half mile before my hands start shaking.
Can I ask you a personal question?
Now would seem an appropriate time.
What if I did the opposite? I'm a cybernetic organism, living tissue over metal endoskeleton.
Tim Ferriss Show.
Hello, boys and girls, ladies and germs. This is Tim Ferriss, and welcome to another episode of The Tim Ferriss Show. You know, I haven't even noted that my standard intro says germs over and over and over again. That may be a bit of foreshadowing for some of our discussion today. Nonetheless, my job normally is to interview world-class performers of all different types, and in some cases, better still, to interview people who have studied many world-class performers, and that is certainly the case today. My guest is, for the second time on the podcast, Walter Isaacson. Walter is a professor of history at Tulane, has been CEO of the Aspen Institute, chair of CEN, and editor of Time. He is the author of many books you will no doubt recognize: Leonardo da Vinci, The Innovators, Steve Jobs, Einstein, subtitle His Life and Universe, Benjamin Franklin, An American Life, and Kissinger, subtitle A Biography. He is co-author of The Wise Men, Six Friends, and the World They Made. His new book is The Codebreaker, subtitle Jennifer Doudna, believe I'm getting that right, Doudna, Gene Editing and the Future of the Human Race. You can find our first conversation from 2017 at tim.blog/Walter. He did a spectacular job, and you can find much more about him at Isaacson, ISAACSON.tulane.edu. Walter, welcome back to the show.
Hey, it's great to be back with you, Tim.
And I have no shortage of material, as usual. We covered a lot of your personal biographical information, many of your practices, writing process, etc., in our last conversation. So I won't spend a lot of time on that. People can listen to our first chat if they want to dive into those topics. But I'm going to ask a few questions before we get into talking about CRISPR and Jennifer and so many other things. And the three questions are going to be, and these are my shorthand notes in front of me: bio of Louis Armstrong, why not? Then the second is professor, and I may have asked you this already, but I want to ask again because I'm curious. Professor, why? Meaning, how did you decide to, on top of, and in addition to everything else that you do, become a professor of history? And then third, just because I want to give people a teaser, Chinese CRISPR babies, how? So there's the why not, the why, and the how. So,
Wow.
so you have so many books you have completed. I honestly just am constantly impressed at how much, not just work, but high quality writing you produce. So I'm curious about the survivorship bias, right? So could you please speak to the bio of Louis Armstrong, or the would-be bio of Louis Armstrong?
Well, any performance I have, it comes from reading your books, Tim. So thanks. And thanks for having me on the show. I learn peak performance, and I try hard to get up to about 10% of what you say I should be able to do. But sometimes you have to put something aside. Leonardo da Vinci knew that because he only finished 12 full paintings and put ones aside that he couldn't get perfect. And I had to do that once with a biography of Louis Armstrong. I'm here in New Orleans, my hometown. I wanted to write about the birth of jazz and Louis Armstrong and race and growing up in New Orleans in the early 20th century. And I listened to all of the recordings he did, the tapes he did of discussions. I read all of his notes and his letters. I went to Corona, Queens, where there's the Louis Armstrong Museum. And after a while, I felt I knew everything there was to know about Louis Armstrong, except for who he was. I didn't know why he was smiling. I didn't know if he was happy. I didn't know if he really liked white people, or, whether his best friend who, was his white manager was somebody he didn't like. And I realized that if you cannot crack the code, you're better off not writing the book.
Are there other subjects you've considered? I'm sure there must be. And begun to work on only to put aside, like so many paintings of Da Vinci's?
Well, I did Ada Lovelace, who in the 1840s and 1850s comes up with the concept of the computer algorithm. And she's the first chapter and the last chapter of my book, The Innovators. And I had tried or considered making an entire biography of her. I went to Oxford University with her letters. She was the daughter of Lord Byron, so her letters are part of the Byron papers there. But unfortunately, there just wasn't enough to make a full-length biography. So I used her as the framing device for the innovators.
We're going to come back to Ada. I want to use that as a device for perhaps introducing a number of topics that we'll revisit later. But so we've checked the why not on Louis Armstrong and the bio thereof. Professor, I'd love to just take a few minutes to chat about this. This is probably not where people are going to start as they chat with you about the new book, but I would just love to know the thought process. How did that come to be? Since you have so many options on the table, you have so many things you could do. And I'm not saying it's a bad choice.
I love students. I love teaching. I feel I learn more from them than they can learn from me. I have this incredible class at Tulane of students who study the history of the digital revolution. And by the end of the class, they're teaching me more as I try to figure out, all right, do I want to join Clubhouse? What do we do on Discord? How can you create a social network for gamers? So I love the stimulation you get from teaching students. Secondly, and this will happen to a lot of people, I was ready to go home. I was born and raised in New Orleans. My parents, my grandparents went to Tulane. I wanted to go back where I could, be part of my roots, get a little bit grounded again after a life of being, at CNN or Aspen Institute. And the way for me was to go home where I've known kids since kindergarten, who are my close friends, to teach their kids and grandkids at Tulane, and to help that process of saying, how can we make things better for the next generation?
What is home? I know you answered this in part already, but what does home mean to you? Because for some people, home is, say, the first city outside of their birthplace where they reside for an extended period after college, for instance. Home can mean different things to different people. What is it that keeps drawing you back?
Well, I'm extraordinarily lucky because some people don't have a particular birthplace or home that they're deeply connected to. But I wake up every morning with a sense of gratitude in a way that I have a community where I was born and raised that's still here in New Orleans. And, they've known me since I was a kid. I've got a lot of family here. And New Orleans is a city that is extraordinarily creative. As you know, this is what your podcast is about. It's also got challenges like every city. It's an incredibly diverse city. And so I found myself coming home, especially after Hurricane Katrina, where I was asked to be the vice chair of the Recovery Authority after that storm. And I realized how badly I miss New Orleans, but also how immersing yourself in a place of great diversity with people who have some frictions and challenge you, but also people who've known you your whole life. So you can't, you got to be true to who you are because they'll cut you right down if you're not. All of that gave me a sense of grounding. And it also gave me the sense, which I think is probably the most important lesson, and you've written about it, but so many other people have, which is, if you wake up every morning and realize how lucky you are, you will be a happier and more creative person. And that can extend even to people who've had a whole lot of challenges in their life. And for me, when I wake up in New Orleans, I think, man, I'm lucky.
The where of happiness, the where of feeling at home, as obvious as that might seem, is just so underestimated. I feel, at least I underestimated it for decades, certainly. I felt like I should be able to be fill in the blank in any location.
What do you call home?
My home is not too far from you. It is now Austin, Texas. It has been for the last 3 to 4 years now, probably closer to 4 years. And when we managed to navigate through this current pandemic and get to some semblance of the other side of the tunnel, then we should have a proper cup of coffee in person. And
Austin is very close to New Orleans, both spiritually and physically, in the sense that they're both places with great music, great university towns, great diversity. and great creativity. So I love going to Austin. I go there all the time. My brother went to UT, and certainly during the Hurricane Katrina, we all evacuated there for a while.
Well, you and I, if I may be so bold, should have, may have. I would love to have a coffee or
I'd love to have more than just a cup of coffee.
It's been a while. It's been a while. And I'm glad you brought up music, because New Orleans showcases a beautiful art form that many know as jazz. And that is, in a sense, a byproduct of diversity, of, one might say, randomness, of, one might say, mutation. So as a metaphor, I think that will also play into a lot of what we discuss. And that is my attempt at a segue to Chinese Crispr babies. so what on earth am I talking about? What do I mean by Chinese Crispr babies? Are we cooking babies? What is this? What is CRISPR?
So 2 years ago in China, a doctor who had been to some of the seminars by the hero of my new book, Jennifer Doudna, had decided to use this technique that Jennifer Doudna and her partner Emmanuel Charpentier invented, for which they won the Nobel Prize in October. And that technique is called CRISPR. And it's based on something bacteria have been doing for 1 billion years, which is keeping track of viruses that attack them and then using a scissors to cut up those viruses if they attack again. Well, you can imagine that's pretty useful in these days of pandemic. But what Jennifer Doudna did was figure out a way to turn that into a tool that could edit our own genes. In other words, if you wanted to edit yourself so that you didn't have sickle cell anemia, that could be done with this tool called CRISPR. And it's already been done. The interesting thing, somewhat controversial, but in some ways very promising, is we can edit our children. We can create what is sometimes called designer babies by saying when they're embryos, early stage embryos, or even reproductive cells, we can say, let's take out the gene that would allow you to get sickle cell anemia or Huntington's disease or cystic fibrosis, so that our children will be genetically healthier. What happened 2 years ago is that for the very first time, in a way that was unauthorized, a scientist in China did that. He edited the embryos of what turned out to be 2 twin girls and edited out the receptor that allows them to get the virus that causes AIDS. And there was an immediate outburst of awe and then some shock because the world wasn't quite ready. It's like Prometheus snatching fire from the gods, or Adam and Eve biting into the apple or something. The world wasn't quite ready for us to be editing our children and creating designer babies. But that's what my book is about, which is, when should we be allowed to edit our children? When should we be allowed to add or take away genetic traits from the human species? And when would that be dangerous to do so, or perhaps even immoral to do so?
I love interviewing you, man. You're so good at this. I just really enjoy it, and
you're not bad yourself.
Thank you. You know, it's a work in progress. I still maybe after another 500, I'll
and
get
that
rid
goes
of.
back to CRISPR. The whole human species is a work in progress. Let's not forget that.
And thank God I can edit my interviews so that I sound better. Whew. The Double Helix. The Double Helix. I want to talk about a little bit of your history first, and then we're going to make a very easy transition to the protagonist of your story. When did you first get exposed to the Double Helix, the book? And what is this book, for those who don't know?
When I was in middle school, my father gave me a copy of James Watson's book, The Double Helix. I just found it recently down here in New Orleans. It has the pale red cover. It was published in the early 1960s, and it's the description of how James Watson and his partner Francis Crick used some of the data by Rosalind Franklin and raced against people like Linus Pauling to be able to discover the structure of DNA. And it was like a detective story. It was about how does life work? What is the secret of life? How do genes work? And I remember reading that, and I look in the margins. I could probably sell it on eBay. It's the first edition of the book. But in the margin are all my, childhood scribblings defining words I didn't know, like biochemistry. And I decided that's really cool. And ever since then, I've had an interest in understanding the joy of understanding how something works, especially when that something is our own selves.
So the protagonist, the main character, as it were, you've chosen to spend so much time on. How did you choose her?
Well, Jennifer Doudna was somebody I'd heard speak out at the Aspen Institute, which I know you know well, and others, about how they had developed this tool to edit human genes and how powerful it'd be in giving us, healthier lives, fighting cancer, fighting coronavirus, it turns out, and how it could make our species healthier, but there was some dangers to that. And at one point, I was talking to her. I said, how did you get interested in it? And she said, I was just in 6th grade, growing up in Hilo, Hawaii. I was sort of an outsider because she's a tall, lanky, blonde girl, but it was in a small village in Hawaii and everybody else was Polynesian. And so she felt kind of a loner. And she came home one day and she said, my dad had left on my bed a copy of this book by James Watson called The Double Helix. And I went, oh, wow, my dad did that as well. And she said, that's when I decided I wanted to become a scientist. I read about Rosalind Franklin in there. And I thought, wow, I didn't realize women could become scientists. And she asked her high school guidance counselor. And the guidance counselor said, no, girls don't become scientists. And that made Jennifer Doudna decide that she would be a scientist. It also made me decide I was going to write about Jennifer Doudna because she did what maybe I should have done after reading The Double Helix, was say, I want to be a research scientist.
So to just allow a preview of the other side of the coin, if we could, and this is just how my mind works, jumping around. We've talked a bit about the possible promises of CRISPR, this gene editing pair of scissors that allows you to do wondrous things, previously unimaginable. What are some of the risks? You alluded to that. Is there a danger, for instance, of customized bioweapons that could be targeted at specific populations? Are there other things that you could mention in brief as real possible risks of this technology? Because it is, as I understand it at least, all things considered, very inexpensive, accessible technology. It is not something that is relegated to the best funded governments, for instance.
About a year after Jennifer Doudna developed this CRISPR gene editing tool, she had a nightmare. And the nightmare was that she had been asked to meet somebody who wanted to understand the tool. And she walks into the room and the person looks up and it's Adolf Hitler. And she realizes that if this technology, like almost any technology, falls into the wrong hands, it could be used for nefarious purposes. The ones you mentioned, like military or obvious ones. You could make a virus, using CRISPR, or some bacteria using CRISPR that was even deadlier than the coronavirus that pandemic we're going through now. You could create, as Vladimir Putin said about a year ago, super soldiers that are stronger and resistant to radiation if you want to fight wars. So that's one thing that could happen. Another thing that could happen is that we decide to make designer babies and design our children. And let's say that you and I decide we want to make sure our children don't have any bad genetic disease like cystic fibrosis or multiple sclerosis or Tay-Sachs or Huntington's disease or sickle cell. That's pretty good. You and I would say that's a good thing for us to be able to edit to make sure our children don't have that. But let's say at the fertility clinic, they also say to you, do you want to make them a little bit taller or have muscle mass? There's an easy gene that at a certain point growing up starts slowing down our growth of muscle mass. You could suppress that gene and have children that were much stronger. And then maybe you could affect their memory, to have them have a much better memory, or have them, have blue eyes. You could change a lot of things. And that leads to a lot of questions. One of which is, should we let the rich buy better genes for their kids? Because these offerings at the genetic supermarket, they're not going to be free. And what would that do to the diversity of our species? You and I talk about the joy of wandering the streets of Austin, Texas, or New Orleans, and we see people tall and skinny, light and dark and gay and straight and trans, and all sorts of traits that they have. It's hard to edit some complex traits, but a few decades from now, we'll be able to edit out traits that somehow or another we feel we don't prefer having in our children. Well, that could be dangerous for the species and for our society.
And for people who want to get a visual on what it might look like to use CRISPR to enhance muscularity, you can look up. Now, this is not CRISPR derived necessarily, because breeding certainly can achieve what CRISPR does, just takes a lot longer. The Belgian blue breed of beef cattle is bred for hyperplasia, which is an increased number of muscle fibers. There may be some myostatin inhibition also, but people can look at that, or bully whippet. If you want to see a whippet, you might envision a very skinny, tiny little dog, very wiry, pretty neurotic looking. Not saying they're neurotic if you own one. And then you add twice or three times the muscle mass. It's pretty shocking, certainly impressive to see, and it's very possible.
The gene for myostatin suppression, after a while, the myostatin reduces, and so you quit building more muscle mass. That's a pretty easy gene to knock out using CRISPR. And that's indeed what happens with double muscling cattle, which you just described. And so they're truly wondrous things we could do, especially, helping people who have some disabilities to make them stronger or better. So before we get scared about CRISPR, we have to realize it can do truly wonderful things. Just this past year, a woman named Victoria Gray, living in Mississippi, was cured of sickle cell anemia. The first time you've had a pure cure using CRISPR.
This is a fantastic introduction, in a sense, connection to the question I was going to ask, because there are lots of athletes who listen to this, and many trainers and coaches and so on. And that was whether CRISPR can be applied to adults, or if it has to be applied at the embryonic stage or the very early stages of life. And you seem to have just answered that.
Let me tell you about a guy named Jason Zahner, by the way, who lives in Austin now, moved from the Bay Area of California. And he's a biohacker. And he has able to use CRISPR and, sort of cooked it up in his own lab. He's a PhD, but he does it, in his basement as a biohacker. And he has created a way to use CRISPR to suppress a bit of the myostatin issue and maybe increase his muscles. And he did it live on a live stream video, injecting himself with it. Now, it didn't really work. You can't do it with just one shot. But he's one of those pioneers that shows what citizen science can do. And eventually, yes, athletes could be able to help increase their muscle mass, or for that matter, their quick reflexes, the twitch muscles, all these sort of things. And so that's going to be interesting. We put a little asterisk next to, McGuire or Canseco or people who use steroids. But what if your genes give you better athletic ability? Do we go from admiring the athlete to admiring their genetic engineer? And what if you could do that in your children, so they are born with genes that give them faster muscle twitch or higher muscles, and they can bend steel with their bare hands? That's going to be both a great opportunity, but also a real challenge.
Good luck, anti-doping committees. This is going to be very challenging. They're already resource constrained. Do not envy that. Sports are going to get very, also with gender identity. I mean, not to get into that topic, but sports are going to become very, very complicated, increasingly so over the next decade. Now, I have in front of me a note, And I'm just going to give you a fragment of it that I would love for you to expand upon. And that is the three fundamental kernels of our existence: the atom, the bit, and the gene. Could I give that to you as a cue and let you run with it?
When I was writing my books, I thought of what are the great innovation revolutions? And there have been three of them. And they start with those fundamental kernels of our existence that were sort of discovered around 1900, which is the atom, and then the notion that all information can be encoded in binary digits, what we now call bits. And finally, the gene. And so when I wrote about Einstein, it was about innovation in the first half of the 20th century based on the theories about the atom, everything from atom bombs to space travel to semiconductors to lasers, all come, that innovation revolution, from that discoveries of physics. The second half of the 20th century, when you and I were growing up, was the information technology revolution, the digital revolution, based on the encoding of all information in bits, the creation of computers that could manipulate those bits, and the creation of an internet or networks that could transmit those bits. The next great revolution is now, and it's based on the gene. It's based on the fact that all of us and our kids who had to learn digital coding will also have to learn genetic coding, because the molecule is going to become the new microchip. It's going to allow us to innovate, to fight coronaviruses, to edit our own genes, to fight cancer. I use Jennifer Doudna as the central character to say what happens when we get to the third great revolution of our time, and it's based on us, our own molecules, our own cells, our own genes.
Do you hope this book will inspire new generations of scientists in the way that the Double Helix did for Jennifer Doudna? Is that one of the motivations?
Absolutely. I would hope that people will read this book and they'll admire the nobility of what research scientists do. Of course, that was sort of a goal of mine 4 or 5 years ago when I started working on it. Now, after these scientists have created vaccines that are going to get us out of this coronavirus pandemic, I think people are primed to say, hey, I admire people who are in the life sciences and figuring out how we can create a healthier species. But I also hope after reading the book, they might leave it on the bed of, some student in high school and hope that they will be inspired to either love science or maybe even be a researcher in science, because there's a joy in figuring out how something works, especially when that something is ourselves. So I want people to feel more connected to science. I want them to feel less intimidated by science, because sometimes when don't like vaccines or you don't like the internet or whatever, it's because you're intimidated by the mysteries of it. And so I want to demystify it, and so that real people like Jennifer Doudna wake up in the morning and they do simple. CRISPR is pretty simple. It's just 3 components. They do simple experiments and they're able to do things that will affect our lives. And I want people who are, kids or raising kids to say, you got to be part not only of the digital generation, but the biotech generation. Even if you're not going to be a scientist, you're going to have to be part of the conversation that says, how are we going to use these new technologies to create vaccines, to fight cancers, to make healthier babies? What are going to be the rules of the road? And in order to be part of that discussion, it's kind of helpful to know what it's all about.
Just a quick thanks to one of our sponsors, and we'll be right back to the show. This episode is brought to you by LinkedIn Jobs. The new year is here, and it marks a fresh start for your small business. Whether you're shifting business hours or hiring more remote employees, one thing that remains unchanged is the importance of having the right people on your team. When your business is ready to make that next hire, LinkedIn Jobs can help by matching your role with qualified candidates so you can find the right person quickly. And to lend a helping hand, your first job post is free. Getting started is easier than ever with new features to help you find qualified candidates quickly from LinkedIn's active community of professionals with more than 722 million members worldwide. Post a job with targeted screening questions to get your role in front of more qualified candidates. You can manage job posts and contact candidates on the familiar LinkedIn.com website, where functions are streamlined into one simple screen. And now you can do all of this from your mobile device, no matter where the day takes you. When your business is ready to make that next hire, find the right person with LinkedIn Jobs. And now you can post a job for free. Just visit linkedin.com/Tim. Again, that's linkedin.com/Tim to post a job for free. Terms and conditions do apply. You mentioned just a moment ago, or you uttered a line that I wrote down because I quite like it, and that is the molecule will become the new microchip. And we're talking about biotech generations and perhaps the differences between what we consider coding education or even just passing coding familiarity, knowing the high-level concepts, even if you are not a coder yourself. And it makes me think of a conversation. I'm not going to mention this person by name because I don't think this was public, but very well-known co-founder of a large company everyone would recognize, who is very involved with conversations around the promises or potentials and threats of artificial intelligence. And before he has a conversation with anyone about AI, he asks them if they have studied computer science, question number one. And number two, if they have kids. And if they can't answer yes to both of those, he just refuses to have the conversation. And the having kids is relevant because it, I think, forces in many people a longer term perspective and just a longer time horizon for considering the consequences of certain things. So if someone, I'm just saying this hypothetically, now or 5 years ago would have been put into sort of computer science 101 with learning, who knows what, I'm not a coder, but Ruby or Perl or God knows what language they end up learning at some point. What does the education look like for someone who wants to better understand the molecule as the new microchip?
Actually, I think it's even simpler. I think that the molecule and the life science is something we all more intuitively understand. Certainly when you do computer science, it's not about Ruby or Ruby on Rails or Perl script or anything like that. It's about the algorithm. It's about thinking sequentially, step by step, logically, so that you can do a computer program. That's the important thing you have to grok if you're going to understand how computers work. But with the life sciences, with genetic coding, it's simply that you have to understand that we have 3 billion base pairs of letters in our DNA. You don't have to know them. You don't have to read, the Human Genome Project study. You just have to know that certain segments of these encode what we call a gene. We're now able to map on our DNA a lot of those genes, the genes that do simple things like cause sickle cell anemia or cause blue eyes. And the question becomes, logically, how can you do things that makes use of the molecules in our body to create things that we want, such as antibodies to fight a virus or to stop your blood from creating sickle cells that are dangerous. So I don't think you need to know the 4 letters of DNA or the similar but slightly different 4 letters of RNA, but you do need to know that DNA encodes our genes, and then RNA is actually the cooler molecule. It actually does some work. It doesn't just curate information. It takes that information and goes to the manufacturing region of our cells and builds a protein. And you say, okay, what type of proteins do we want? Antibodies for a virus? Let's build that. Proteins that will make our blood healthier? Let's do that. And so just this general concept of how our bodies work, I think is useful whether you're an athlete or a creative person or just somebody who wants to be part of society. And it's not that complicated. You don't need to know a whole lot of Boolean algebra or math in order to do life sciences. You just need to know this central dogma of biology that our genes turn RNA into worker bees that build proteins in our cells. Okay, now what are we going to do with that?
I think many of these toolkits, right, whether it's familiarity with the algorithms, right, in some respects, the recipes of computer science or those types of technologies, and then sort of biochemical or genetic fluency, I think that those will very often go increasingly hand in hand, right? I was looking at a list earlier today from 2007, which was one of those lists you see a lot, right? The 100 greatest living geniuses. And this is from 2007. One must keep in mind because we have someone, at least one, who's passed away. I think Tim Berners-Lee is still with us. But the first place, this is from the Daily Telegraph. So think what you may of the Daily Telegraph. The first place position was tied between Tim Berners-Lee, who is, I suppose, best known as a computer scientist who was one of the inventors or co-inventors of the World Wide Web. Brilliant man. And yes, he is still living. I just confirmed. And Albert Hoffman, a name people may not recognize, who was the first person to synthesize LSD-25, also psilocybin, and many other things like hydergine, which is used for cognitive function and age-related dementia. So you have a computer scientist and a chemist side by side. And I think that is just going to increasingly be the case. You mentioned proteins. We're going to have protein folding, and how proteins fold is a big problem that computers do very well with. But let's move to the personal. Jennifer Doudna, there are a few phrases that I picked out of what you said. Nobility of scientists. So there are noble scientists, and then there are ignoble scientists. Simple experiments. What makes Jennifer special? Right? Because there are a lot of scientists, and just like in the field of medicine, where like
Right.
P equals MD is a joke among a lot of my doctor friends, pass equals medical doctor. In other words, there's the kind of good, the bad, and the ugly. So what makes her special?
You know, you write a lot about performance and creativity, and I have found that the simplest component of it is curiosity. You know, Jennifer Doudna was persistently, obsessively, and joyfully curious. Even growing up in Hawaii, she'd touch a piece of what's called sleeping grass and it would curl up. And she kept wondering, why does that happen? Why does it curl? And she'd look at the spirals of the seashells and she'd say, how does an animal create that? And when I saw that she was doing that, I realized Leonardo da Vinci did the same thing with spirals and shells and curls and trying to figure it out. And you can see it even in the Mona Lisa, her curls. So that curiosity about everyday things, like I'm looking out now in New Orleans and there's the bluest of blue skies. People who are curious say, well, why is the sky blue? Leonardo da Vinci asked that, Einstein asked it, and Jennifer Doudna asked questions like that. So not outgrowing our wonder years, being able to stay relentlessly curious, that's what caused Jennifer Doudna to keep saying, all right, I've just seen this thing, but how does it really work? What's inside of our bodies, of our molecules, of our cells that causes this to work? And she discovers some of the key clues of how things work, one of which is the structure of molecules, how the structure of RNA allows it to build certain proteins. And so I think if I were to say, how can you be creative as a scientist, or for that matter, as a musician or athlete, it would be curious about everything, all walks of life, arts and sciences, technology and the humanities. That's what Steve Jobs did. He had one foot in the arts, another foot in technology, and he did not make a distinction between those two. That's what Leonardo's Vitruvian Man is about. It's a work of art and it's a work of science, and he didn't make a distinction between those two. And for Jennifer Doudna, she doesn't make a great distinction between the life sciences and the humanities. And by being curious about all things, she's able to see the patterns in nature.
I'd love for you to comment a bit more on this particular species of curiosity. And the reason I ask is that there are many scientists out there, and there are many diligent, hardworking scientists out there, but very few are able to achieve what Jennifer and her collaborators have been able to achieve. Furthermore, I would say that science is great for a lot of things. The scientific method is excellent for testing hypotheses. It doesn't really offer you a fail-safe way of generating good hypotheses, right? So was she just asking better questions? I'd love to hear you comment on any or all of that.
She asked better questions, but most importantly, she cared about curiosity-driven science, what we call basic scientists. Sometimes scientists, and for that matter, people in the world of tech, are always keeping their eye on the application. How can I make something useful out of it? How can I make money out of it? My book is about a group of scientists who discover the natural phenomenon of Crispr, which is just a basic science curiosity, which is, hey, I've looked at bacteria and they have clustered, repeated sequences in their DNA. That's hard to explain. Those clustered, repeated sequences get dubbed CRISPR. Nobody was looking to create a gene editing tool. And initially, they weren't looking for things like how do we protect yogurt cultures from being attacked by viruses, although it turns out to be useful for that. They were driven by curiosity, pure curiosity, to pursue basic science. And then the applications follow. One day, Jennifer Doudna has finally cracked the code of how CRISPR works in bacteria to fight off viruses. And she makes it work in a test tube so that it can cut a piece of DNA at a designated spot. That experiment was done just out of basic science research curiosity. But the minute they succeeded, they looked at themselves in the lab and they said, this could be a tool to edit our genes. So the advice is, don't always look for how it's going to be applied. Be curious about the basic science. And at some point, the usefulness and the applications will follow.
You have written about, profiled, acted as biographer of quite a few people. If you had to compare Jennifer to previous subjects, who is she most similar to, and in what ways?
She's most similar to Benjamin Franklin because she's curious about a wide variety of things, but then also, and here's a key part of the book I write about, at a certain point, after she has a nightmare about Adolf Hitler, she becomes enmeshed in understanding the moral and policy implications of what she's done. So like Benjamin Franklin, she's interested in basic science, but she's also interested in policy. She's interested in governance. And she connects science. And let's remember, Ben Franklin was a great scientist. I mean, he discovers the single fluid theory of electricity. But having understand the balances and checks and balances in Newtonian physics and in electricity and the plus minuses and ledgers, he helps create a constitution that will hold together for centuries based on checks and balances. Jennifer Doudna also applies her science and her discoveries to how is it going to affect the human species and to our national society. And so that's why and she's also just a good person. She's joyful. She really cares about other people. Some of the people I've written about have been a bit strong cups of tea. But I think Jennifer Doudna and Ben Franklin would sit there over a glass of ale or a mug of beer, and they would laugh and they would tell jokes and they would understand the foibles of their fellow human beings, but they would love them. And so I would love if I could have a dinner party to have Jennifer Doudna and Ben Franklin there.
All right, we're going to come back to that because I would like to know, and this is just a bookmark, so we're going to come back to this, but if Jennifer is competitive in any particular ways that make her more similar to, say, a Jobs than a Franklin, I don't know the answer to that, but I'd be curious to explore the nature of scientific competition and how that factors into the story. But before we do that, I have some cleanup to do. We mentioned Ada Lovelace earlier. I said I was going to come back to her. So I do want to do that very quickly because it may relate to other things we talk about. In our first conversation, I think the wording that came up was that Ada Lovelace pushed herself to understand that a mathematical equation is just nature's brushstroke for painting something in reality. I think that is roughly the wording, which is just incredible. Mm-hmm. And what I don't think we talked about, which may or may not be relevant to things in this conversation, is Ada Lovelace's objection and how it contrasts with, say, Alan Turing. Is that something you could speak to?
Yeah, Alan Turing in his famous paper, Can Machines Think?, which was written 100 years after Ada Lovelace published her notes on the analytical engine. Ada Lovelace says machines will be able to do anything that can be notated in symbols. They'll be able to process music and words and numbers and patterns. They'll be able to do everything except for originate thought. They won't be able to be creative. And the purpose will be to marry our machines to our own human creativity. So she didn't believe in the pursuit of what we call artificial intelligence. She didn't believe that would be as fruitful as the pursuit of what we now call augmented intelligence, the symbiosis where we connect machines and humans more closely. And I think that's because she was the daughter of Lord Byron, but she was a mathematician. So she had a poetic sensibility where she could look at a line of her father's poetry, like she walks in beauty like the night, and visualize it. But she could also look at an algorithm or a mathematical sequence and visualize it as well. And so this ability to connect the humanities to technology, that's what she's the patron saint of. So she feels we aren't going to get artificial intelligence. We're going to try to get the symbiosis of human machines to create augmented intelligence. Alan Turing is the other school of thought. He refers to that as Lady Lovelace's objection, and his paper, his famous paper, I think published maybe in 1950 in Mind magazine, is soon we'll have an imitation game test, and we'll be able to show that machines can think in a way that's indistinguishable from the way humans can think. Now, you all can debate, all your listeners can debate that. I'm not sure we have an answer. I'm not sure 50 years from now we'll have a clean answer to those questions.
Oh boy, that could be a whole nother podcast. Maybe it will be. So thank you for answering that. And it does connect to the sort of cross-disciplinary, interdisciplinary lens through which you have attributed to Jennifer Doudna. And before we go specific to Jennifer and her story and talking about competition and where sort of scientific races figure into this, I just want to ask a question more broadly about curiosity, because it's one of those words that I think can probably, I haven't done this, but can probably be parsed into very different types of curiosity. And you mentioned asking why. And there are people who are very good at asking why and do it in very productive ways. There are investors I know who ask why 3 times, just as a matter of course. That is just their policy if they're talking to a startup founder, to uncover assumptions. That's why they ask why. But then there are people who ask why from a not necessarily skeptical perspective, but a cynical perspective, right? And those lines of argument don't often, or I shouldn't say don't always, lead to productive places. And when you're speaking to Ada Lovelace and poetry, I couldn't help but wonder, and this is a leading question, of course, does the common breed of curiosity that we observe in, say, an Ada or a Jennifer or a Ben Franklin entail a necessary seeking of wonder or awe? Is there a motivation behind the curiosity that is shared?
I think it's a seeking of wonder, as you said, and most importantly, it's an open-minded inquiry. As Ben Franklin would say, let the experiments be made. As Jennifer Doudna did, it wasn't trying to prove some pre-existing hypothesis. It was, let's follow the facts, and then let each experiment we do inform how we're going to test something out. we have lost that ability, which is at the core of both the scientific method and of the Enlightenment that helps create this country, which is be open-minded. Don't have a preconceived hypothesis that you're trying to prove. Have a sense of wonder and a curiosity to see where the facts lead you. And that's how Ben Franklin makes a list of all the facts he's discovered about sparks and all the things he's observed about lightning and figures out the lightning rod. And that's how Jennifer Doudna looks at this mysterious way that bacteria fight virus attacks and says, let me figure out why does it work?
And I want to underscore how important this is. And I say that speaking as someone who has had to learn this over time with respect to basic science, and as someone who funds a lot of science right now, a lot of scientific research, that it is sometimes a mistake to be in a rush to force the application or to insist on an application. Those applications, some of the most important discoveries that have ever been made in human history, and gene editing, CRISPR may certainly be one of them, have come about as emergent from basic science. I just think that's so important from a funding perspective, from a sort of scientific literacy perspective. So I'm really glad we're talking about it. So let's talk about something a little more, I don't want to call it crass, but human competition. Jennifer and, is it Emmanuel? Am I getting that right?
Emmanuel Charpentier, yes.
Yes. Go from observation to, in a sense, having in their hand a tool. And whether they are motivated or not by prestige or money, they're smart enough to realize that they are sitting on something very, very potentially important and massively impactful. Can you describe the race that ensues?
I love competition, just like most of your listeners probably do. And I think competition spurs us to go faster, aim higher, do amazing things. And part of competition is racing both to get the credit for something and sometimes to get the intellectual property, the patents for something so that you can fund your research. So when Jennifer Doudna and Emmanuel Charpentier discover that this system bacteria have been using to fight viruses can be used as a tool by us to edit our own genes, they get into a race, or Jennifer Doudna gets into a race with other scientists to say, okay, let's show how we can do that in a living human cell. Because she had done it in a test tube. The question is, will it actually work if we try to do it in the cell of a living being like us? And the strongest competitors are Jennifer Doudna at Berkeley on one side, and this wonderful guy named Feng Zhang, born in China but raised in Iowa and has sort of a corn-fed smile and enthusiasm. And he's at the Broad Institute of MIT and Harvard. And so for 6 months, they, along with some other scientists, race to see who can be the first to prove that this amazing new tool will actually work in human cells. And Feng Zhang wins the race by about a couple of weeks. In other words, he publishes in January 2013, and Jennifer Doudna publishes at the end of January 2013.
My God.
And they've been locked in a patent battle ever since. And people say, isn't that horrible? I say, no, this is why competition spurs us to do good things. But here's something cool. Both of them have turned their attention in the past year to using these technologies to fight the coronavirus, just like bacteria use it to fight viruses. They use it to detect the virus. And this time around, they're racing to publish papers on it, but they're putting them in the public domain. They're allowing people to use whatever they discover if they're using it to fight the coronavirus. So sometimes you have to be competitive. Sometimes you have to be cooperative. Sometimes you have to try to invent things that you get, the patents to. And sometimes you put things in the public domain. There's no one easy answer. And I hate people have knee-jerk reactions that they hate all patents or they think all patents should be enforced forever. It should be like in your town of Austin and all when Texas Instruments does the microchip and Bob Noyce does a microchip, eventually they shake hands and say, let's make this useful for the world.
So I'd love to just bring up a number of points, I think, that surfaced in what you just said. One of them relates to scientific funding. For people who don't know, performing science it can be extremely expensive. It very often is extremely expensive. It takes a lot of money. And one of the mechanisms by which scientists can fund their research, because it requires funding, requires people, requires space, requires tools very often, is with technology transfer. So within universities, many universities, certainly at places like MIT, Harvard, et cetera, you will have technology transfer offices, and the university will license technologies. And if the researchers involved have intellectual property, they're sometimes able to take a portion of those proceeds and use it to allow them to continue their research or do new, expanded, more ambitious studies and research. So I just wanted to mention that. Profit is not always a bad thing. Money is not always a bad thing. In fact, it is most often a necessary component of scientific breakthroughs in this day and age.
We would not have vaccines against coronavirus had there not been a race to understand how RNA can be a messenger in our body to make proteins, something that everybody from Jennifer Doudna to a group at the University of Pennsylvania did so well, is figure these things out. And figuring it out is not something you can do in a dorm room, like inventing Facebook or inventing, an algorithm for Google or something. It's something that takes a lot of lab space and a lot of investment. So we have to have a system in which discoveries are used for the common good, but also people can benefit from having made discoveries and use the proceeds in order to fund their research.
Hear, hear. Yeah, humans, present company included, respond to incentives. Human behavior in a lot of ways is the study of incentives. And animal behavior, any behavior really. And it's important to recognize that the scientists also need resources.
I try very hard to say, what are those motivations? And I look at Jennifer Doudna and Fong Zhang and the others who have done it. And I don't think money is the main motivator, but it does fund the research. I also think, acclaim. People just want people to say, wow, congratulations, you did something. Or better yet, give them the Nobel Prize for having done something. That motivates them as well. But the thing I've discovered about the scientists in this book is that they're also just motivated by curiosity and the belief that science is a noble endeavor. It will make our lives better. And I believe that sort of at the beginning of the book. But then when I watch the coronavirus hit and I watch how people have been cured of things like sickle cell anemia by CRISPR, the gene editing tool, I realize that more than most people, scientists have a whole group of motivations, but that noble endeavor of making the world a better place is certainly one of the main ones.
I'd love to come back to COVID, or more accurately, to pandemics for a moment, and sort of do a retrospective and then perhaps explore a bit of forward-looking subjects. So please correct me if I'm wrong. Have you interviewed the author of The Great Influenza, subtitle The Epic Story of the Deadliest Plague in History?
Not only have I interviewed him, I live here in the French Quarter, and if I craned my neck enough, I'd see John Barry's house. I'm on Royal Street. He's actually a couple blocks away, I think on Burgundy Street. But I run into John all the time. Just ran into him when walking back from the gym in the French Quarter. So I love John Barry's work. It's great narrative history.
What have you learned from him or his work? I know that's a very broad question, but what are some of the insights or counterintuitive learnings or memorable points that come to mind when I ask that question?
When I read about the 1918 pandemic, that epidemic that John Barry wrote about, the first thing I marvel at is how little things have changed. I mean, there they are trying to call off parades in Philadelphia, or wearing masks and getting people to wear masks and social distancing, the same sort of things we've been wrestling with for the past year. But the thing that impresses me now is that we've invented a new type of vaccine. Back in 1918, vaccinations were pretty rudimentary. They were done the same way that Edward Jenner did a century earlier, which is to give you some facsimile of the virus or bacteria you were trying to fight, see if your antibodies would do so. But now, along with people like Jennifer Doudna and other code breakers, we've invented a way to have RNA tell our cells, build these antigens that will fight the virus. So suddenly we've had a quantum leap so that the human species in its 100,000-year war against viruses now suddenly is taking the lead and might be able to beat back pandemics in the future.
Let's hop, not to continue to bring it back to this, but to sort of moral concerns. You mentioned Doudna and her dream of Hitler, and I mentioned Albert Hoffman earlier, who synthesized LSD, was the first to consume it as a synthetic, at least. And the title of one of his books was LSD, subtitle My Problem Child. And he had a lot of thoughts on the applications and misapplications. Certainly that's true for a lot of the scientists who worked on the Manhattan Project and nuclear weapons. What scenarios or possible events keep Jennifer up at night or sit in her mind, if you know, or could speculate?
Yes, there's a whole part of my book, the last quarter of my book, besides dealing with fighting the coronavirus, deals with Jennifer Doudna and her friends and colleagues wrestling with what are the moral implications. And as with any technology, whether it be the atom bomb or Facebook, how we use that technology can be for good or for bad. And so Jennifer Doudna is wrestling with how do we make rules of the road and guidelines that we can agree to internationally. She creates summits of scientists internationally to say, here's how we're going to use it for the time being, at least. And they've agreed to certain rules, which is you only should use it when it's truly medically necessary. In other words, if it's the best possible way to fight Huntington's or sickle cell anemia, and that's medically necessary, then it makes sense to use it. But you don't use it for unnecessary enhancements, like let's make our kids taller or let's change their hair color. And I think as we go along, we're going to have to feel our way, which is why in the book I spend time looking step by step how they've gone through the different moral issues and then having our own thought experiments where we can figure out what would happen if we went into a fertility clinic and they gave us a menu of things we could choose. What would we choose? And then think about the downsides if everybody gets, or all rich people get to make those choices. So it's not, a one sentence answer for how should we use this technology. It's going to be something that over the next 20 years, we and our children and our grandchildren are going to have to appreciate how cool and wonderful genetic editing can be, but also how we have to have some guidelines.
Do you have any thoughts, or have you heard any thoughts on how we can create guidelines that are actually enforceable in a sense? And I don't want to sound too much like Hobbes and Leviathan or anything like that. But in contrast to some of my friends, I tend to have a skeptical view of sort of the altruistic default of human nature, and I'm very interested in how we can create sort of systems instead of depending on best intentions, because there's so many motivations that can warp best intentions, even the best of intentions. Do you have any thoughts on what maybe instead of guidelines, guide rails can be established in any way?
I think it's going to be hard to enforce too many guidelines because unlike the atom bomb, which I could not make in my basement or even in my Tulane University labs or something, CRISPR is something that is relatively easy to do. As we said, the rogue scientists in China did it 2 years ago and edited the embryos of babies. And even I went to Berkeley to Jennifer Doudna's lab and have a chapter where I am taught how to edit the genes of a human cell. Now, lest you worry about it, once I finished, we flushed it down a drain with a lot of chlorine, so I didn't create some Frankenstein's monster. But it's something any graduate student in biology could do, and eventually we'll find ways to deliver those edits more safely into human beings. So it's going to be hard to enforce it. But there are things that are hard to enforce, whether it be the trafficking in elephant tusks or, for that matter, sex trafficking or shoplifting or running red lights. But as societies, we find ways, not that we can ban it entirely, but we find ways to make it something that's illegal to do, is hard to do, is shameful to do. And a few people might break those laws, but at least we can keep it under control. And I think that's what we're going to have to do with the bad uses of gene editing technology. And that's what Jennifer Doudna wrestles with. How do we create those guidelines and try to find some ways we can have some good enforcement of them?
If you had to choose an aspect of the book, an aspect of this technology or the story that you think people might not pay enough attention to, right? There's certain things that I think no doubt you communicate very, very clearly. And perhaps there's something that you worry people might miss because it's not a huge feature in the book, but nonetheless very important. Is there anything like that?
The big thing I fear that people might miss is that if you don't read the book, you might have a knee-jerk reaction, just like people have to genetically modified organisms or, food or corn that's been GMOs, those type of things. And it's fine to have a strong opinion about GMOs, but it's also useful to know what a gene is before you have such a strong opinion. And I would hope that people keep an open mind, just like great scientists and great people who are curious and creative. They keep an open mind because there are both good and bad things that can come of this, but mainly good things. And so we shouldn't have a knee-jerk reaction and say, oh, this is horrible, we're playing God, or we're messing with Mother Nature. Well, if you want to talk about playing God, nature and nature's God have created a species that has evolved enough to learn how to influence its own genetic evolution. And that species is us. So this is natural that we have learned these things, and we shouldn't have knee-jerk reactions to it based on not understanding it. And so I hope people will reserve judgment on what type of genetic editing, what type of vaccines, what type of uses we should do with our molecules in order to fight viruses, not have a knee-jerk reaction until you see the wonders of the exploration and keep an open mind about how the technology can be used for really great things like alleviating suffering and also potentially be used by people with less good intentions.
And I would add to that, thank you for saying all that and answering the question. And I would add to that whether you like something or not is oftentimes kind of irrelevant in the sense that if it is, and it is not going to go back to is not, then particularly when it has the culture shaping arc of history bending potential of something like this, I feel like it is certainly helpful and in some ways incumbent upon us to have a basic understanding, if we can develop such an understanding of something like CRISPR. I mean, it is, not to overstate the case, but I think we will look back at this kind of with that Promethean perspective that you mentioned earlier.
Absolutely. This is the most important invention of our time, I think. The ability to edit our genes and to program our molecules to do things like create immunity to viruses. And like any technology, it can be used for good or for bad. And I think we have to understand it so that we can all have a conversation about it. And we should be open to the beauties and the wonders that got us there. Sometimes our moral thinking has trouble keeping up with our discoveries. That happened with the atom bomb. And then we had to say, okay, now let's wrestle with it morally after we dropped it twice. That, frankly, in my mind, has happened with social networks, where it kind of got ahead of our moral thinking about how can these best be used to connect us as a society. So if we're going to keep our moral thinking aligned with our new discoveries and innovations, we have to understand those new discoveries and innovations, and we have to know the story behind them. We have to ask the question that you ask all the time, which is why?
Why? Yeah, and why not? Also, it strikes me that never before have the questions of philosophy that might have been considered entertaining thought exercises for freshman philosophy 101, never before have they been so incredibly important and of practical implication. If you look at AI, if you look at programming autonomous vehicles to, say, have to choose between hitting 2 children on the sidewalk versus 3 adults in the road, that is a decision that this car, the programming needs to be able to make. And with CRISPR, similarly, many of these philosophical questions are no longer abstract discussions over a bottle of wine. They actually are pressing in some respects.
I think these are the questions we're going to have to face in the next 20 years. So it's good to start understanding how it happened now. And I love the fact that you say it's not just questions of why, but also questions of why not. When I was writing this book, as I got near the end, and when Jennifer Doudna was thinking through the moral issues, she not only asked, why would we do something like that? But after a while, when people who have kids with, problematic genetic defects or horrible, conditions such as Huntington's or sickle cell, she'd say, well, why not fix it? Wouldn't we consider it immoral not to be using this new technology? So we don't have to just ask, why would we use the new technology? But sometimes we have to say, why not? Wouldn't there be something morally wrong about not helping to cure people, even if it means we're doing it through genetic editing?
Walter, I think this is a great place to begin to wrap up. I always have so much fun in our conversations. And is there anything that you would like to add? Any closing comments, questions to pose to my audience, requests to make of my audience? Anything at all that you'd like to add before we slowly wind this to a close?
I think the one request is to help get everyone to understand the nobility and the beauty of science and open inquiry, but then also being able to walk into the future, into this mysterious new room we're about to enter, with a sense of hope and optimism so that we can figure it out step by step, cautiously, so it doesn't become a slippery slope. Slopes are less slippery if we do it step by step, hand in hand. And I think that's what we're going to have to do as we watch this new biotech revolution help us make our own molecules into microchips that we get to program.
Walter Isaacson, I want to take your class, sir.
My class is online. It's on YouTube if you can find it.
We will link to it.
I'll come to Austin too, and we'll hear some good music. We'll eat some good food. We'll have a home and away games. I'll listen to some Austin music, and you can come hear some funk and jazz here in the French Quarter.
I would love that. And Walter, thank you for the time. Your newest book for everyone listening is The Codebreaker, subtitled Jennifer Doudna, Gene Editing and the Future of the Human Race. You can find Walter at isaacson.tulane.edu. And the gumbo and some coffee and some music is a date. Good sir.
Thank you very much.
Hey guys, this is Tim again. Just a few more things before you take off. Number one, this is 5 Bullet Friday. Do you want to get a short email from me? Would you enjoy getting a short email from me every Friday that provides a little morsel of fun before the weekend? And 5 Bullet Friday is a very short email where I share the coolest things I've found or that I've been pondering over the week. That could include favorite new albums that I've discovered. It could include gizmos and gadgets and all sorts of weird shit that I've somehow dug up in the world of the esoteric as I do. It could include favorite articles that I've read and that I've shared with my close friends, for instance. And it's very short. It's just a little tiny bite of goodness before you head off for the weekend. So if you want to receive that, check it out. Just go to 4hourworkweek.com. That's 4hourworkweek.com, all spelled out, and just drop in your email and you will get the very next one. And if you sign up, I hope you enjoy it. This episode is brought to you by 8 Sleep. My God, am I in love with 8 Sleep. Good sleep is the ultimate game changer. More than 30% of Americans struggle with sleep, and I'm a member of that sad group. Temperature is one of the main causes of poor sleep, and heat has always been my nemesis. I've suffered for decades, tossing and turning, throwing blankets off, putting them back on, and repeating ad nauseum. But now, I am falling asleep in record time, faster than ever. Why? Because I'm using a simple device called the Pod Pro Cover by 8 Sleep. It's the easiest and fastest way to sleep at the perfect temperature. It pairs dynamic cooling and heating with biometric tracking to offer the most advanced but most user-friendly solution on the market. I polled all of you guys on social media about the best tools for sleep, enhancing sleep, and 8 Sleep was by far and away the crowd favorite. I mean, people were just raving fans of this. So I used it, and here we are. Add the Pod Pro cover to your current mattress and start sleeping as cool as 55 degrees Fahrenheit or as hot as 110 degrees Fahrenheit. It also splits your bed in half, so your partner can choose a totally different temperature. My girlfriend runs hot all the time. She doesn't need cooling. She loves the heat, and we can have our own bespoke temperatures on either side, which is exactly what we're doing. Now, for me, and for many people, the result, 8 Sleep users fall asleep up to 32% faster, reduce sleep interruptions by up to 40%, and get more restful sleep overall. I can personally attest to this because I track it in all sorts of ways. It's the total solution for enhanced recovery, so you can take on the next day feeling refreshed. And now, my dear listeners, that's you guys, you can get $250 off of the Pod Pro cover. That's a lot. Simply go to 8sleep.com/Tim or use code TIM. That's 8, all spelled out, EIGHT, sleep.com/Tim, or use coupon code TIM, TIM. 8sleep.com/Tim for $200 off your Pod Pro cover. This episode is brought to you by Magic Spoon. Magic Spoon is a brand new cereal that I eat just about every day that is low carb, high protein, and 0 sugar. I just ate a huge bowl of their cocoa flavor about an hour ago after a short workout. Magic Spoon cereal has received a lot of attention since launching last year. Time magazine included it in their list of best inventions of 2019, and Forbes called it the future of cereal. It tastes just like your favorite sugary cereal from childhood, remember that? But it's actually good for you. Each serving has 11 grams of protein, 3 grams of net carbs, 0 grams of sugar, and only 110 calories. It's also gluten-free, grain-free, keto-friendly, soy-free, and GMO-free. All the things. It's delicious. And I don't say that lightly because most of this healthy version of X stuff is not delicious, but these guys really nail it. Magic Spoon has nailed it. It comes in your favorite traditional cereal flavors like cocoa, frosted, and blueberry. You can try them all by grabbing a variety pack at magicspoon.com/Tim, or you can just grab a box or a bunch of boxes. I'm going to order some more today of the cocoa, which is my personal favorite. But there's a new contender for favorite flavor because they just launched 2 limited edition flavors, honey nut and peanut butter, which are delicious. I am a sucker for peanut butter, and it is outstanding. So I think cocoa and peanut butter are my 2 new favorite flavors. And fun fact, my friends are also obsessed with Magic Spoon. One of the podcasts Most popular guest, Dr. Peter Attia, routinely crushes 6 to 7 servings at a time, that's a lot, with no glycemic response. He's looked at this with a glucometer. He likes it so much he invested. Other friends, 2 very fine gentlemen, and also past podcast guests, Kevin Rose and Ryan Holiday, also invested. So go to magicspoon.com/Tim to grab some delicious cereal and try it for yourself today. Use promo code TIM, that's TIM, at checkout to save $5 off of your order. And Magic Spoon is so confident in their product, I have boxes and boxes and boxes. It's backed with a 100% happiness guarantee. So if you don't like it for any reason, they'll refund your money, no questions asked. Get your next delicious bowl of guilt-free cereal at magicspoon.com/Tim and use the code TIM to get $5 off.